and welcome to the next module of this course on continuous integration and continuous delivery with Jenkins pipelines. In the last module, we went through detailed steps for installing and configuring our Jenkins instance, and we also ran some jobs on our Jenkins server. After installing our Jenkins instance and going through a simple pipeline job, now it is time to kick things into high gear. In this module, we will take a look at creation of CI and CD pipelines for real-world projects. So let's get started. Before we dive into the project, let's get familiar with the overall structure of the project and the components we will be using in this project. The sample project is a simple Java-based REST API project which exposes one simple endpoint. We picked a simplistic project for these demos because our main focus will be the integration of these projects with our Jenkins pipeline. In your environment, you could follow similar steps to integrate any similar project to build with your Jenkins pipeline. Anyway, so our source code will be managed by our source control provider, which in our case is Git. For our Git source control, we will use Bitbucket. Bitbucket is a web-based source control hosting service for projects that use Git revision control systems. Bitbucket offers both commercial plans and free accounts. It offers free accounts with an unlimited number of private repositories. Bitbucket is very similar to GitHub in the functionality it provides. For our build framework, we will use Gradle. Gradle is an open-source build automation system that builds upon the concepts of Apache Ant and Apache Maven and introduces a Groovy-based domain-specific language, DSL, instead of the XML format used by Apache Maven when declaring the project configuration. We will build our source code automatically using a sophisticated Jenkins job. This job will pull the source from our Git repository and produce the required Java artifacts. These artifacts will be stored in an artifact repository manager. A repository manager is a software tool designed to optimize the download and storage of binary files used and produced in software development. It centralizes the management of all the binary artifacts generated and used by the organization to overcome the complexity arising from the diversity of binary artifact types, their position in the overall workflow, and the dependencies between them. A repository is a software repository for packages, artifacts, and their corresponding metadata. It can be used to store binary files produced by an organization itself, such as product releases and nightly product builds, or for third-party binaries, which must be treated differently for both technical and legal reasons. For the repository manager, we will use a product called JFrog Artifactory. Artifactory is a universal artifact repository manager which fully supports software packages created by any language or technology, which means we can use it to store artifacts produced from Java, .NET, Python, or any other framework. Artifactory integrates with all major CI, CD, and DevOps tools like Jenkins, TeamCity, TFS, etc. And it provides an end-to-end, automated, and reliable solution for tracking artifacts from development to production. Everything we are using here is completely free and open source. All right, folks, let's start by reviewing our source code for our API project. Here we have navigated to our Bitbucket repository for our project, and we were looking at the master branch of our project. Since we're using Gradle as our build system, we need to have this build.gradle file in the root folder of our project. This build.gradle file is the build definition file for our Gradle build system. It contains information and instructions for Gradle to build our project along with all the required dependencies. This build definition file is a prerequisite for Gradle to be able to build our project. So please make sure this build.gradle file is located precisely in your root folder. Gradle will search for this build definition file within the internal directory structure of your project. Let's review our build definition. At the top is the build script, and it lists the repositories we are going to use and the dependencies for this project. These dependencies signify that we will be using Artifactory for storing our artifacts. Same goes for plugins here. And we are using JUnit for running our unit tests. And last but not least, we have some more options specified for Artifactory. It has information like the target URL for our Artifactory instance. Now let's head back to our source code repository hosted on Bitbucket and navigate to our API folder, where we can see we have this API called person list, and we also have this package.html file. Okay, so after reviewing our source files, let's move ahead with building our continuous integration and continuous delivery pipeline. Let's get back to our Jenkins homepage and create a new Jenkins job. Click on this handy link, Create New Jobs, to start a new job creation wizard. Let's name the project Gradle_build_tetranoodle and choose Freestyle Project as the project type. Okay, great. Let's start configuring our job. First of all, let's configure the option to discard old builds. Let's say we want to keep our builds for 4 days, and we want the last 6 builds to be kept for historical and tracking purposes. This configuration will take care of that. You can adjust these numbers based on your preference. Next, we need to configure our source code management so that Jenkins can pull our source code from our repository. Since we are using Git for our source code, we select Git as our selection. To integrate our Jenkins instance with our Bitbucket repository, we will need to provide the repository URL for our repository. You can get this repository URL by navigating to Bitbucket and clicking on the Overview link. The repository link is available here at the top right corner. We will copy it verbatim and paste it back into our Jenkins job configuration under the repository URL field. After configuring our repository, we can also configure credentials so that our Jenkins instance can access our repository. But in our case, we can accept the default value of none because our source repository is public and we do not really need any credentials to be able to access it. That means that anyone can clone our project without any credentials. If our project were private, we would have specified credentials right here in our build definition. You can insert username here and your password for the Bitbucket account, just like this. Okay, it looks like everything is configured correctly. Let's apply these settings and save our job. By the way, the process of integrating Jenkins and Bitbucket is really simple. All you needed was the public URL of our repository to enable this integration. But in case you are using a different source code provider, you may need to install additional plugins to integrate Jenkins with your target source control provider. For instance, say you want GitLab as your source control provider. Then you would need to install the GitLab plugin into Jenkins to make them work together. Let's quickly see how we can configure a different SCM, like GitLab, with Jenkins. Let's click on Manage Jenkins, link on the left menu, and click on Manage Plugins. Now switch to Available tab to access the list of plugins which are available to us. Here we will search for GitLab for our required plugin. This GitLab plugin will allow us to connect our Jenkins instance with GitLab. The actual process of integration is pretty similar to how we connected our Jenkins plugin with Bitbucket. The only difference is that you need this plugin in order to enable the integration with GitLab. You can check out this and other plugins in case you have some special requirements to satisfy. Okay, great. Let's continue and connect our Jenkins with Artifactory open source. Here we are in our Artifactory repository manager. As discussed earlier, Artifactory is a special repository based on Apache Tomcat that can easily store all your artifacts. What does it mean to store artifacts? When a software build process, for example, a Jenkins build with our little REST API, is completed with the help of Gradle, in the end it will produce a jar or war file. This jar or war file could be an executable or a deployable file, and this file is called an artifact. Our artifact repository manager can easily manage multiple versions of this file. Once the artifact has been added to our Artifactory repository manager, individuals like our team members or partners who have access to this repository can review the artifact, its version, the metadata, etc. They can browse the available versions and download the required version and install it on their system. The whole workflow to publish, manage, and consume these artifacts becomes much smoother and secure using a repository manager like Artifactory. Alright, before we move forward, let's review our environment for the Artifactory instance. Basically, we have deployed Artifactory on a local virtual machine, and this virtual machine has been deployed with a bridged network mode, which means we will not be able to resolve the IP address for our virtual machine directly via our DNS server. So in order to get around that problem, we will just update our host files to force a DNS resolution to our target machine. We will get the IP address from our virtual machine by executing IPA command, and in order to get the complete host name, we will just execute the command hostname. First, we will copy the target IP address from our virtual machine. In our case, this IP address is 192.168.0.104. We will map it to a DNS URL of art.noodle.tetra. Now let's first map this IP and DNS URL on our main host Windows machine. We will open a new Windows command prompt with administrator privileges and navigate to System folder and then to /drivers/etc. folder, and here we will need to open the host file with a text editor like Notepad. We have already added the entry to map our Artifactory machine's IP address with the desired DNS URL. After configuring it as so, our host machine will be able to access our Artifactory instance using the DNS URL. Furthermore, we need to do similar configuration changes on our Jenkins host machine as well, so that it can also easily access our Artifactory instance. So let's head to our Jenkins virtual machine and edit our host file on our Linux instance with the VI editor. You will notice the structure of the host file is very similar to the host files on Windows. And now we have mapped our DNS entries for the Artifactory instance by updating our host files. And because of the special architecture of Jenkins, we need to create two entries. One for the base DNS hostname, art.noodle.tetra, and another one for the HTTP endpoint for our Artifactory server, http://art.noodle.tetra/, so that Jenkins can access both these endpoints without any issues. The next step is to install a special add-on to integrate Artifactory with Jenkins. Let's navigate to the Manage Jenkins screen and click on Manage Plugins. Here we are in the plugin management area. If you have not installed the Artifactory plugin, then you will need to access the Available tab to look for the Artifactory plugin. But on this particular Jenkins instance, we have already installed this particular plugin. So in this case, it is listed on the Installed tab. In order to install this plugin, you will need to go to the available list of plugins and search for the Artifactory plugin. This plugin will allow you to connect your Jenkins with Artifactory open source instance, which we installed in previous demos. Once you find this plugin, you will need to select and install the plugin in your Jenkins instance. The Artifactory plugin also requires us to provide additional configuration to be able to connect to Artifactory. So let's make sure it is properly configured now. We will click on Manage Jenkins menu on the left-hand side and then click on Configure System, and then on the configuration screen. Scroll down to find the Artifactory section. This section was added into our configuration page after we installed the Artifactory plugin. Currently, Jenkins does not know anything about our Artifactory server. So let's click Add to add a new Artifactory server configuration. First, we need to provide an identifier for our server. The value could be anything, as long as it is unique. We will just use the artifact server DNS URL to make it easier to recognize and remember. Next, we need to provide the URL where our Artifactory server is installed. If you recall, we already updated our host files with the required DNS mapping. So our Jenkins server should be able to connect our Artifactory server using this endpoint without a problem. After that, all we need to do is specify the username and password for our Artifactory server. We will use the administrator user we set up earlier for Artifactory. One word of caution. For production environments, please use a specific user with the least amount of privileges. For the purpose of this course and for the sake of convenience, we are using the admin user. Now, after setting up our server like so, let's test our connection. Okay, the connection failed. We forgot to append Artifactory to our URL. There we go. After fixing that minor error, let's test the connection again. Great! Our Jenkins was able to connect successfully to our Artifactory server, and as a part of this initial handshake, it also downloaded some version information about our server, which further verifies that Jenkins is successfully connecting to the right Artifactory server. Now that Artifactory is connected to the Jenkins server, we can continue to configure our build job for our Java API code. Now let's click on the Gradle_build_tetranoodle job, and on this build homepage, let's click on Configure menu on the left side to update its build definition. Scroll down to the build environment section, and here we will select the Gradle Artifactory integration. Now we need to select the target Artifactory server. This job definition already recognized the server which we configured in the global Jenkins settings, and it is being listed here in the list of valid known Artifactory servers. Now, since we only have one Artifactory server configured, we will just pick this default value. Next, we need to pick the target repository within the Artifactory server where we want to publish our artifacts. Rather than manually type the name and copy and paste it from Artifactory, we can click on this refresh button, and Jenkins will pull the list of repositories from the target Artifactory server. As you can see, the plugin is quite user-friendly and easy to use. For now, let's pick this repository, Release Local. We will not change anything under resolution details because it is not applicable to the current project we are trying to build. If the Jenkins job is using a plugin to interact with the Artifactory server, we need to enable this option. Project uses the Artifactory Gradle plugin. Our case, for example, we are using the Artifactory plugin, as we can verify by reviewing our build.gradle file. Here is the plugin. com.jfrog.artifactory, which means that within our Jenkins build, we definitely must enable this option. Otherwise, our build will not be wired up correctly. Let's make sure this option, Publish Artifacts to Artifactory, is also enabled because that is exactly what we need to do. Most other options are optional and we can accept the default values for them. Now let's go to the build section and add a build step. Build steps are the basic building blocks for the Jenkins freestyle build process. These steps are what define the flow of a build job and instruct Jenkins exactly how to build the project. A build job may have one step or more. It may even occasionally have none. In a freestyle build, you can add as many build steps as you want to the build section of your project configuration. There are various types of build steps available to us. Since we are using Gradle as our build framework, let's pick Invoke Gradle Script. And now, a bunch of new options are available to us for configuring this Gradle script step. Let's take a closer look at this build action, because it is a really important step for this build job. Jenkins presents us with two options to configure this Invoke Gradle script. The first one is to simply invoke Gradle, where all we need to do is choose the Gradle version. And the second option is to choose a Gradle wrapper. Most tools require installation on your computer before you can use them. If the installation and configuration of these tools is easy, then it is not a big issue. We can install them manually and we are good to go. But in some cases, it can be an unnecessary burden on the users of the build. Before they can build their projects, they have to go through a series of manual installation and configuration tasks for all the tools they intend to use in their build jobs. This could be quite a tedious task. More importantly, as new versions of these tools are released, we also need to worry about whether the server will have the compatible version of the tool installed. What if they're building an old version of the software? The Gradle wrapper solves both these problems and is the preferred way of starting a Gradle build. Let's discuss the Invoke Gradle option first. This option allows us to use one of the particular versions of Gradle wrapper which has been installed and configured within the current instance of your Jenkins server. As alluded to earlier, Gradle wrapper is the Gradle provided mechanism to embed the use of a specific Gradle version in a build. If the required version is not available, the wrapper installs the necessary version before continuing with the build. In order to use the Invoke Gradle option, we need to configure a particular version of Gradle. Let's do that now. We will go to Jenkins homepage and then click on Manage Jenkins menu on the left-hand side, then click on the Global Tool Configuration link. The Gradle plugin for Jenkins provides automatic installation for Gradle, which can be performed by directly downloading from the Gradle website, extracting a compressed file, or executing some shell commands. Besides that, for Jenkins instances which already have Gradle installed, the plugin can be manually configured by unchecking the Install Automatically checkbox and providing the base path of installation. This path is configured via the Gradle home environment variable. In fact, the name of the variable could be anything. Once configured, Jenkins will attempt to use this particular installation of Gradle for any Gradle-related build steps. Jenkins will use the Gradle executable from the bin directory of your Gradle home. If the Jenkins instance does not have Gradle installed, you can also pick this option to install Gradle automatically. Once we have configured our Gradle instance, we can use it for any of our jobs. Speaking of which, let's head back to our job build definition. Here we can see that if we select Invoke Gradle option, we are provided with the list of installed and configured Gradle instances. In this case, the only instance we have is the instance appropriately named Gradle. Having said that, the recommended option is to use the Gradle wrapper for these types of build tasks. Why is that? Because Gradle wrapper allows Jenkins to download the necessary files and executables from the internet exactly as needed by the Jenkins build job. What does that mean? Well, it means that anytime any Jenkins job needs Gradle, this wrapper will take care of the installation and configuration of Gradle. It is a much more efficient and robust method to use this option, especially if you're deploying the job on multiple servers, in which case you can do away with the hassle of installing and configuring Gradle manually. The Gradle wrapper will take care of it for you. All we need to do is click here and enable this option, Make Gradle W executable, and to apply and save. Gradle W is the command for Gradle wrapper. With that, We have completed the build definition for our job. And now we are ready to run our first job and review the results. Let's click on the Build Now button to kick off a new build. You will notice that a new build is now showing up in the build history list. Let's go to console output to monitor this build in real time. This is the output log, which Jenkins produces as it is running our Jenkins job. It is fairly verbose and could be daunting to look at initially. But once you get familiar with it, you will find it invaluable to monitor and troubleshoot your jobs in real time. Let's review the log for the current execution. First, we can see that our job is trying to connect to our Git repository. It finds the latest revisions or commits in our source repository. Then it pulls all the source code for the latest revision of our API project. Once downloaded, Jenkins will start to build our source code. For building our source, it is going to use the Gradle framework. But notice how it is using the Gradle W execution, which is the Gradle wrapper with this special option of Artifactory Publish. So as you can see, Gradle wrapper is downloading the necessary Gradle version from the internet along with all the necessary dependencies. Let's wait for a few moments for it to install and configure the required files. Now it looks like our code has been successfully built and our job has produced a jar file. Last but not least, our job has also successfully deployed our jar artifact along with the build descriptor into the target repository within our Artifactory server. The job also outputs a handy link to the location where our artifacts were deployed. Let's click on this link and head to our Artifactory server and verify the deployment. And here we are. We are in the build browser section of our Artifactory server, where it is providing us all the metadata information about this build. We see that the name of this build is Gradle_build_tetranoodle, and it is the first build number. To check our artifact, we need to go to the Artifactory repository browser and move to the repository where we instructed our Jenkins job to deploy the artifacts to. If you recall, we picked ext-release-local. Here it is. Underneath this repo, we see our jar file. That is the artifact which Jenkins created as an output of our build job. Once selected, we have a lot more metadata information available about this artifact. Let's recap what you learned in this module. First, you implemented a Jenkins job for the Java API project. Next, you installed and configured our Artifactory plugin for Jenkins. Then you updated your Jenkins job and integrated it with Artifactory. Last but not least, you ran your job and deployed the build artifacts from your Jenkins server into your artifact repository.